The first circuit that we come across in Lab 5 is the NOR-SR circuit. The NOR-SR circuit has the default state of S is equal to 0 and R is equal to 0. The S input will set Q to 1, and the R input resets Q to 0. Here we have throwaway values when both the S and R inputs are set to 1. As you can see from our expected results, this means that when S is set to 1, Q plus goes to 1 and Q naught plus goes to 0. The exact opposite occurs when R is set to 1, Q plus will go to 0 and Q naught plus will go to 1. As you can see from our Logisim diagram, the S input goes on the top and the R input goes on the bottom. In the middle, we have two NOR gates that are cross-coupled with each other in a cross-feedback loop. And then on the right-hand side, Q naught goes on the top while Q goes on the bottom NOR gate. On our actual results over there on the right-hand side, you can see that everything does go according to the expected results other than that last part at the bottom when both are set to 1. And in that situation, we get 0 on both the Q and the Q naught outputs. And that brings us to our Nand Sr latch. The Nand Sr has a bit of an opposite behavior to a NOR Sr, meaning that the default state for this one is S equals to 1 and R equals 1. When S is set to 0, Q is set to 1, and when R is set to 0, Q is reset to 0. Our don't care values here are when S and R are equal to 0 at the same time. In the actual results, we again see a somewhat opposite behavior of the NOR-SR latch, meaning that when S and R are both set to 0, instead of the don't care values, in real life what we see is that Q and Q naught are set to 1. Other than that, everything turns out exactly like it's supposed to in the expected results. One thing of note here is with a NAND latch, the Q and the Q naught on the right-hand side of the diagram are switched.
D-latches have one data input and a gate that is used to tell the latch when to accept input. As such, we expect that our gate will remain unchanged unless the gate is set to 1. When the gate is set to 1, we then expect the output to be set to whatever the input was, regardless of its previous state. A D-latch is made using a NOT gate, two AND gates, and a NOR latch. Our gate, which is here at the bottom, is attached to both of our ANDs. And what the gate does is this is what allows, you set this to allow our data to pass through. Our data line up here at the top, we actually kind of split it here. It goes one into the AND, then we take the inverse of it and take it into the other. We then feed that into our NOR latch, which will then store our data. The benefit this has over other types of latches is that it only requires the one input. So it only requires us to change our data value here. And then our gate is the only thing that can say, okay, yes, that goes through, or no, stop it. Gates can also be used to, like one gate can control multiple latches. So you can set it to open all of our latches and allow all of our new data through, or we need to stop them, and this will be the final point for it right now. So those are the benefits of a D-latch. And if we go through our inputs on the D-latch, it proves our results from what we expected.
Also covered in this lab. A switch debounce. This is caused when the signal in this situation bounces up and down. This is why we use the term bounce. A switch bounce can be fixed with a switch debounce and can be resolved with flip-flops known as cross-coupled NOR gates. In timing specifications, we learn about specification sheets, also known as data sheets. This gives us instructions of a timing setup time, hold time, and frequency. We learned different components has different limitations, meaning each situations may vary. From this, we learn to be aware of the limitations of a given circuit.
So in conclusion, we just wanted to go over the importance of timing specifications, what we learned, and why all of this is important. So timing specifications are important because with our circuits, if we don't have these stats, we won't be able to correctly get our timings right. And you could have misfires through your circuits, and depending on what you're building, this could end up really bad. And other things that we learned in this is we learned how data is actually stored using latches. So these latches there's different types that perform differently. And this kit is all used in things we use every day, especially those latches. Those are used in our in registries as well as in our random access memory, or RAM, in our smartphones, computers, laptops, anything that needs to store data. Thank you.